Black holes are often described as the most terrifying objects in the universe. They are portrayed as cosmic monsters, bottomless pits that swallow stars, tear planets apart, and trap light itself. In science fiction, they are portals to other dimensions, engines of destruction, or gateways to time travel. But behind the myths and exaggerations lies something far more fascinating. Black holes are not monsters by intention. They are monsters by gravity. To understand black holes, you must first let go of how you imagine space and time. In everyday life, gravity feels weak. You can defeat the gravity of an entire planet simply by jumping. But gravity is deceptive. It is patient. It never turns off. And when enough mass is squeezed into a small enough space, gravity becomes absolute. That is when black holes are born. Every black hole begins its story as a star. Stars exist because of a delicate balance. Gravity constantly tries to pull a star inward, crushing it under its own weight. At the same time, nuclear fusion in the star's core pushes outward, releasing enormous energy. For millions or even billions of years, these two forces are locked in a stalemate. As long as fusion continues, the star lives. But stars are not infinite. When a massive star runs out of fuel, fusion slows and eventually stops. The outward pressure disappears. Gravity no longer has an opponent. And in that moment, the star loses the fight it has been winning its entire life. The core collapses. In less than a second, gravity crushes the star's core inward at a significant fraction of the speed of light. Atoms are destroyed. Electrons are forced into protons. Space itself begins to bend inward. If the star is massive enough, nothing can stop the collapse. Not pressure, not energy, not even the structure of matter itself. The result is a black hole. A black hole is not an object floating in space like a planet or a star. It is a region of space where gravity has become so strong that escape is impossible. Once something enters this region, all possible futures lead deeper inward. The boundary of this region is called the event horizon. The event horizon is not a physical surface. There is no wall, no barrier, no dramatic explosion when you cross it. It is simply the distance from the center where the escape velocity exceeds the speed of light. Beyond this point, nothing returns. Not light, not matter, not information as far as we know. From far away, a black hole appears invisible. It emits no light of its own, but its presence is betrayed by its effects. Stars orbit unseen masses. Gas heats up and glows as it spirals inward. Entire regions of space twist and distort under its gravitational grip. To an outside observer, something falling toward a black hole appears to slow down as it approaches the event horizon. Its light stretches and reddens, fading away until it seems frozen in time. But for the falling object itself, something very different happens. It falls normally. It crosses the event horizon without noticing anything special. There is no alarm, no signal, no moment that says, "Now you are doomed." The laws of physics feel ordinary, at least at first. And that is what makes black holes so unsettling. The point of no return has no warning. At the center of a black hole lies the singularity. This is where our understanding of the universe collapses. The singularity is a point of infinite density, where all the mass of the black hole is crushed into an infinitely small space. Here, space and time cease to behave as we know them. Our equations produce infinities. Our theories contradict themselves. We do not know what truly exists at a singularity. It may be a point. It may be a ring. It may be something else entirely. Black holes are not all the same. Some are relatively small, formed from the deaths of massive stars. These stellar mass black holes can be several times the mass of our Sun, packed into a region smaller than a city. They lurk throughout galaxies, often quietly, often unnoticed. Others are far more extreme. At the center of almost every large galaxy lies a supermassive black hole. These giants contain millions or even billions of times the mass of the Sun. Our own Milky Way is anchored by one, Sagittarius A*, a black hole 4 million times more massive than the Sun. Despite its enormous power, it is currently quiet, slowly feeding on gas and dust. If it were active, it would unleash jets of energy that could outshine the entire galaxy. Supermassive black holes are not accidents. They grew alongside galaxies, shaping their evolution. Their gravity influences how stars form, how gas moves, and how galaxies evolve over billions of years. In this sense, black holes are not merely destroyers. They are architects. One of the greatest misconceptions about black holes is that they endlessly consume everything around them. They do not. If our sun were magically replaced by a black hole of the same mass, the planets would continue orbiting almost exactly as they do now. Earth would not be pulled in. The gravitational field would remain unchanged. Black holes only become dangerous when you get too close. What makes them special is not how much gravity they have, but how concentrated that gravity is. As matter falls toward a black hole, it forms an accretion disk, a swirling, superheated ring of gas and dust. Friction and magnetic forces heat this material to millions of degrees, causing it to glow brighter than entire stars. Some black holes also launch enormous jets of particles at nearly the speed of light, blasting radiation thousands of light years into space. These jets can shape entire galaxies, shutting down or triggering star formation. Black holes are extreme, but they are not chaotic. They obey the laws of physics with ruthless consistency, and yet they reveal something deeply uncomfortable. They expose the limits of knowledge. Inside a black hole, our understanding of reality ends. Space and time lose their meaning. Cause and effect blur. Information appears to be destroyed, challenging the foundations of physics itself. This has led scientists to some of the deepest questions ever asked. Does information truly disappear inside a black hole? If it does, then the universe is fundamentally unpredictable. If it does not, where is it stored? Some theories suggest it is encoded on the event horizon itself, like a cosmic memory etched into space. Others propose that black holes eventually evaporate through a process known as Hawking radiation, slowly leaking their mass back into the universe over unimaginable timescales. If this is true, then black holes are not eternal. They die too, but their deaths are slow, so slow that even the smallest black holes will outlive stars, galaxies, and possibly the universe as we know it. Black holes force us to confront an uncomfortable truth. The universe does not care about intuition. It does not care about comfort. It follows rules that are elegant, brutal, and often indifferent to meaning. And yet, black holes also connect us to the cosmos in a profound way. Every black hole is born from a star. Every atom in your body was forged in stars that lived and died long before Earth existed. In some sense, black holes are distant cousins, formed from the same stellar ancestors that made life possible. They are reminders that creation and destruction are not opposites. They are the same process, viewed from different angles. For beginners, black holes may seem terrifying, but they are also invitations. They invite us to question reality, to explore the limits of physics, and to accept that the universe is far stranger than imagination. Black holes are not holes in space. They are holes in understanding. And by studying them, we learn not only about gravity, but about time, existence, and the fragile place we occupy in the cosmos. This is why black holes continue to haunt human thought, not because they destroy worlds, but because they show us how close reality comes to the edge of the unknowable. This is the mystery explored by World's 1001 Mysteries. If this journey into gravity's darkest creations changed how you see the universe, share your thoughts below. Do black holes terrify you or inspire you? Like the video, subscribe to World's 1001 Mysteries, and turn on notifications for our next exploration into the unknown. Until then, remember, the universe is not gentle, but it is endlessly fascinating, and the deepest monsters are often the greatest teachers.